Another thing that I would like to mention is that I sent out yesterday, took me my entire conference period to send out emails to mamas and daddies that students are failing. So this class is too easy to fail. You really just have to come to class and do the work. And if you fail something, you correct it and you get your grade up or you retake it. So if you are failing, that is totally on you and you need to do something about it. If you are absent or you miss, then it is your responsibility to log in and you need to go on Canvas and you need to get the missing work taken care of. I go through half of every worksheet online. So you guys need to correct those or go back and you need to finish the things that you missed when you're out. There's like 2 weeks left to get your grade up if you are failing. And this is not like the last 2 years where, well, I'm probably going to get passed on. No, you're not going to get passed on. Like you will fail my class. I promise. If you do not do anything about your grade will stay what it is and you will fail. Now, I'm not talking to very many of you, but there are some of you in here that need to do something to rectify your grade. Today, we're going to talk about probability. Probability is how likely something is to happen. Probability is how likely something is to happen. Emmanuel, can you please go put your phone on the wall and get a calculator? Thank you. To find probability, there's this formula. So I put the formula on there. Probability of something happening is equal to the number of things you want to happen over the total possible outcomes. So let's get started. Question number 1 says a computer store has 36 computers in stock. 6 are black. If Ulysses buys a computer at this store and randomly selects her computer from inventory, what's the probability that her computer will not be black? So we know how many black computers there are. How many not black computers are there? 30. So the amount of things that you want to happen, there are 30 possible not black out of the total, which is 36. When you're dealing with probability, it is typically either a reduced fraction or a decimal. So let's first reduce that fraction. They're both even numbers, so we could start with that. So 30 divided by 2 is 15, and then 36 divided by 2 is 16. Can that reduce any further? Yes, no? Mm-mm. All right, let's find it as a decimal. 15 out of 16, or what is that as a decimal? Hello? No, she got brought back from the counselor. So maybe ask Miss Johnston? I guess, I don't know. She was brought back to the door and there was a thumbs up and okay. Yeah, no problem. Bye. Okay, 0.93. We would also call that a 93% chance. Most likely she's gonna get a not black computer. What is the probability that her computer will be black? You do that one on your own. What is the probability that her computer will be black? There is an issue with the first one. Did anybody find it? Does anybody see the mistake on the first problem?
On the what?
The first, part A, there's a mistake. On part A, there is a mistake. Does anybody see it? What's 36 divided by 2? Yeah, not 16. Nobody even checked me.
I was like, that can't be right.
It's still morning. So our percent's going to be different. So 15 out of 18. Oh, can that reduce actually? Yeah, but I think that can reduce one more time because 3 goes into both of those. 3 goes into 15 5 times and 3 goes into 18 6 times. And so yes, 0.83, which is 83%. So hopefully you were able to do part B, and to know that you did it correctly, the percents of both of them should add up to 100 because it's black and then not black. So that's how I knew that we did something wrong. The next question, 3 fair coins are to be tossed simultaneously. What does simultaneously mean? At the same time. So we're tossing these coins all at the same time. What's the probability of getting at least 1 tails? Here's what we have to do with problems like this. We got to write out what could possibly happen. So as we write this out, I could toss them all and I could get heads, 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 right? Mm-hmm. I could toss them and I could get heads, heads, tails. I could toss them and I could get heads, tails, heads. I could get tails, heads, heads. I could get all tails. So I'm going to stop speaking this out loud. I want you to try and just keep writing them down. All I'm doing is kind of changing what each one of them are, trying to get all possibilities. Okay, I think I've written them all. When you write them all, there's 8 possibilities total. I know that there are 8 because there are 2 sides or 2 possibilities for each one, and we're throwing 3 of them. So 2 to the 3rd power is 8. So I know there are 8 possibilities, but it's easier when you write out all the possibilities. Once you write them out, it's what's the probability of getting at least 1 tail? Well, how many possible combinations are there? 8. There's 8. So everything, if we're talking about these things, they're out of 8. So out of 8, And what's the probability of getting at least one tails? Okay, well then we need to go through and we need to identify things that are one tails. So make sure you're using a pencil because each question is going to be a little different. I'm just going to go through and I'm going to check everything that has tails. At least one tails is what it says. Okay, so how many out of 8 have one tail? 7. At least one tail. So the only one that doesn't have one is the all heads. So when you type that in, what is our decimal? Okay, 0.875. I would say that that's 88%. So what's the probability of getting 2 heads? I'm going to erase my checks and I'm going to go through it and mark anything that has 2 heads. So it doesn't say more than 2 heads. So the top one doesn't work because that's not 2, it's 3. That is 2. That is 2. That is 2. I think those are the only ones that just have 2 heads. Do y'all agree? Okay, so I would say 3 out of 8. 3 out of 8. What is that? I would say that that is 38%. You're gonna do the last one on your own. What's the probability of getting both heads and tails? So you just need to have both of them. So whenever you have a problem and it's talking about flipping more than one coin, please make sure that you write out the possibilities. It's always 8. It's always 8. But it's good to see these combinations so that you can figure out what these questions are asking. It's really hard to visualize without this list. Next question. Kevin, Drew, and Beth will each present a report in class, and the order in which they present the reports will be chosen at random. There should be a comma right here. Kevin, Drew, and Beth. What's the probability that Kevin will deliver his report before Drew? So we're gonna have to do the same thing. We're gonna have to write out like situations. There could be Kevin and then Drew and then Beth. So all I'm gonna do is start rearranging these. It could be Kevin, Drew, Beth. Kevin, Beth, Drew. Hello. Thanks. Jaden Davis. At 125, you've got a college thing. Does anybody see any different ones? Okay, I agree. There's 6 different possibilities. So the first question, what's the probability that Kevin, if there's 6 possibilities, first we know that it's out of 6. Kevin delivers his report before Drew. So I'm just assuming that on the left is first, second, third for who's presenting. So Kevin delivering before Drew. So that's K before D, K before D, K before D. I only see 3 where the K comes before the D. Anybody else see any different ones? Okay, so that looks like 3 out of 6. What's that? Does that reduce? Yeah, 1/2. What's that as a decimal? 0.5, and yes, it is 50%. The next question, what is the probability that Beth will present first? Or what is the probability that Drew will present last? You got 2 minutes. I think you can do those on your own. Yep. Yeah. Okie dokie. We are going to move on. The next question says, John has 5 friends who are available to go with him to a basketball game, but he only has 2 extra tickets. How many different choices does John have to invite these 2 friends? So we don't know what their names are, but we're going to just say that he's got 5 tickets. So A, B, C, D, E. We're going to say that the 5 friends are A, B, C, D, and E to make it easy. What did I say?
What?
Did I?
It's a basketball.
Did I really?
It's like what? It's a basketball.
Maybe I was kind of like a hybrid of baseball and basketball.
That's what I said, laughing.
Yeah, I was thinking, what's so funny? Yeah, I would probably laugh too. Yeah, I know baseball. Maybe I was thinking baseball and basketball. I don't know. I have no words. A, B, C, D, E. So those are his 5 friends. They're going to see a basketball game. And he's just picking 2 at random. So again, I'm gonna do the same thing that I've been doing. I'm gonna just write it out. So he could pick A and B, A and C, A and D, A and E. The list isn't as long as you think it would be. Okay, then I'm gonna go down to the B's. So I'm not gonna write B and A because I already have B and A as A and B. It doesn't matter, that's still the same 2 people. So B and C, B and D, and then B and E. I'm gonna stop talking so that you guys can write them out too. So does everybody see how there's kind of a pattern as you start writing it? It's not that bad. It kind of is a little pattern, and every time you get 1 less. I'm not going to give you a quiz or a test question that has like 25 possibilities. It's going to always be like 10 or less. So as you write these out, you figure out that there are 10 possibilities. Drawing a blank. Every way that I feel like I'm writing possibilities sounds wrong. P-O-S-S-I?
Yes.
Possibility. Oh, no, I-E-S. Because it's not really a probability. It's like 10 choices, 10 possibilities. That doesn't look right to me. Is that right? It seems like a lot of eyes, right? Does that seem right to y'all? And me too. That's what I'm saying. This does not seem right. We're gonna have to Google that. That's what I was thinking. I guess. Seems like a lot of eyes. Okay, whatever. The next question, what is the probability of selecting a male from a group of 4 males and 8 females? You're going to do this one on your own. You got 4 males and 8 females. What is the probability of picking a male? So remember, probability is what you want to happen out of the total amount of possibilities. So you got to figure out how many people there are and how many males there are. Okie dokie, we're going to move on. And since I am having a rough time this morning, I need to do some eye yoga.
Oh, yeah.
I'm having a rough morning. I might need to get up and walk around the room.
I'll go with the rest of it.
Take a field trip around the block. On to the back at Froyo. I came up with that name. Isn't that clever? You would think that they would already have a place, right? At Froyo, a customer can select one flavor, one type of cone, one type of fat content, and one topping from the table shown below. So you've got vanilla chocolate swirl, no cone, cake cone, waffle cone, fat-free, low fat, or chocolate sauce or nuts. So how many different combinations are possible? This is actually a lot.
Yeah.
This is actually a lot. There is actually an easier way to do this. For this one, you've got to figure out how many are in each list. So flavors. We have 3 flavors, 3 cones, 2 fats, and 2 toppings. That is exactly what you do. So see if you can figure out how many possibilities. What'd y'all get? So it's 36 combinations. So now you're gonna go and do the other 2. What if they're out of waffle cones? What if they're out of nuts? So see if you can figure out those combinations. You want to grab the worksheet? We're on the back of it. You got it. No, it's just how many combinations. So all you got to do is eliminate one of the things and then you just multiply it across. You should check with the people sitting around you. The next question. Layla is playing a game where she has to roll a fair number cube with faces labeled 1 to 6. What do we call a fair number cube? Starts with the letter D. What is a fair number cube? Yes. some resources don't let us write dice because they feel like it's like suggesting gambling. But we're gonna say a fair number cube is a dice. Or I suppose singular is a die. That's okay. So Layla is rolling a dice. It's got sides 1 to 6. What's the probability that she will roll either a 3 or a 4? So how many total like possibilities are there? Well, we've got a 1, a 2, a 3, a 4, a 5, and a 6. So 6 outcomes. What's the probability that she will roll a 3 or a 4? So how many? Yeah, it's 2 out of 6. So 2 out of 6, that can definitely reduce. What does that reduce to? 1 out of 3. What is that as a decimal? So 0.33, which is 33%. Good job. You are going to do B and C. And it's okay to talk to your people.
Round it up.
If it should round up, absolutely.
You know how to make mirrors?
No, I have something even better.
How to make hot dogs? Yeah. About how to make hot dogs.
I have something better. Okie dokie, moving on. There are 20 children in the cast of a play. 8 of the children are boys. Of the boys, 4 have a speaking part in the play. And of the girls, 8 do not have a speaking part in the play. If a child from the cast of the play is chosen at random, what is the probability that that child has a speaking part? Well, let's try and illustrate the situation. So we have we have 20 kids. And it says that we have boys and we have girls. And so it says 8 of the kids are boys. So boys, and there are 8 of them. And then if there are 8 boys, then how many girls are there? 12. So we got 12, and these are girls. And then for each of the boys and girls, some have a speaking part, some do not have a speaking part. For same for the girls, some speak, some don't speak. So they either speak or don't speak, speak or don't speak. So then it says of the boys, 4 have a speaking part. So 4 have a speaking part, and how many don't speak? 4. And then for the girls, of the girls, 8 do not have a speaking part. So 8 go over here with do not speak. So then how many of them do speak? 4. All right. So the question says, if a child is chosen at random, what's the probability that the child has a speaking part? So we got to figure out who speaks. So we got how many total kids speak? 8. How many kids are in the play? 20. That certainly reduces. They're both even numbers. So 8 divided by 2 is 4. 20 divided by 2 is 10. They're both even numbers, so I can reduce still. 4 divided by 2 is 2, and then 10 divided by 2 is 5. So we've got a reduced fraction. What is that as a decimal? Or a 40% chance that you get a kid that is speaking. All right.
Oh, yeah.
Logan, I have the greatest hearing.
Okay, I just wanted to get it past the commercial.
Oh, Kit Kats are made.
That's it. It's you.
Those don't look like Kit Kats.
You don't. Okay, that's crackers.
Those are sugar cookies.
That says how biscuits are made at the bottom. And at the top, it says how Kit Kats are made. Maybe it's gonna get to the Kit Kats next.
That was inside. Oh.
I can't do this if they don't talk. I'm here talking.
Those
look really good.
You don't need them.
I do, I need speaking.
Where's the Kit Kat? That's what I was trying to win. Biscuits.
Here's Kit
Oh,
Kat.
there we go. We're at the Kit Kat factory.
Chocolate.
Are they gonna speak?
Oh
No.
my God.
Oh,
So nice. Oh,
Oh no, there's subtitles.
look at that.
why is there no talking?
There's subtitles. That tells them what to do.
Do y'all like it with no talking?
Yeah.
It's fine.
Ugh.
Super
There's
sad.
subtitles, so it's fine.
Oh my God.
They're cool. Robot stacks, finished wafers. Where are they?
That one machine has that guy.
Stack. What?
Ooh, that looked cool.
That was nice.
That's satisfying.
Oh my gosh.
Uh,
So satisfying. Look how clean that stuff is. That's how you eat Kit Kat. Oh my god.
How much chocolate?
Too much.
Oh, those are like the little twin size.
Wish I was at the end of the career, though. Shut that. Open it up.
They'd be slapping you in the face.
What? Oh, it's nice. Now imagine the biggest guy in the world. Which is I'm gonna make that. Man, those are the old cat.
And there's a, oh, they're like the,
Dare you?
What?
How dare you? You're making me hungry for a Kit Kat. Box. Ice cream. Yes.
do y'all want to watch ice cream too?
Let's watch all of it.
Okay. Are they gonna put that in the ice cream?
Or these ice cream sandwiches?
Oh,
What? Oh, that's.
I would have never thought that.
These are the ice cream sandwiches.
I did not know that's how they did it.
I like that.
This is so satisfying. This is so satisfying.
The ice cream seems like there's a lot.
Yeah.
Like when I get them, they're not that thick.
Yeah.
Maybe it shrinks.
Maybe it like presses it down.
How cold is it in there? Oh my god. Is there nothing else? What?
How does the bottom stick on?
I don't know.
I am mind blown. I didn't know that's how it did it.
It's crazy how fast they're not even melting at all.
It must be super cold.
Mine.
And this is just like ice cream. And these are containers of ice cream.
Okay. Cool.
And then the lids get pressed on.
That's like, I might have to mouth
Oh.
one.
I thought you said, can I see your monster drink? You want to see how monsters are made. I'll have to put that on the list.
You get a gallon of sugar to make one. Shit. They grind up Energizer batteries and put them in a drink. I don't like this one.
Oh, they're gonna put nuts on it.
Oh,
Those are
Oh,
the cones.
what the heck just happened?
I didn't think that's what that was.
There you.
-35 Celsius is that?
It's cold.
I want ice cream.
Huh.
Oh my gosh.
Oh, I don't know what I did.
That was nice. I like that.
Huh. Well,
Very satisfying.
now we know. We didn't know, but now we know.
You made me hungry, how dare you?
Yeah, I'm hungry too.
Ah,
The only thing that would be better is if I had Kit Kats to give to everybody.
Oh,
buy some
I'll have to
Kit
get some. I'll get some.
you know my dream.
Kats. Yeah, why not?
So Jenny rolls a standard die labeled 1 to 6. She rolls 100 times. Which of the following experimental outcomes is not likely? So let's think about this as just rolling the dice. If we are rolling a dice, remember that a dice has 1, 2, 3, 4, 5, 6. We're going to roll a number greater than 2. So how many numbers are bigger than 2? Yeah, we've got 4 bigger than 2. So 4 out of 6. What is that as a decimal? What? Okay, so 0.67, what'd you say? Okay, so we would say that that's a 67%. Okay, let's do the next one. 50 rolls will show an even number. Okay, how many even numbers do we got? I'm gonna erase my checks. Even numbers, I got 2, 4, 6. That's half of them, right? So 1/2, that would be 50%. Okay, the next one, rolling a number less than 4. So a number less than 4. Yeah, I would say that that's 3 out of 6. That's another 1/2 or 50%. And then the next one says a number less than 3. So that would be 2 and 1. So that's 2 out of 6. What is 2 out of 6 as a decimal? Okay, 0.33 or 33%. All right, so let's go back and read the question. The question is saying, which of the following is not likely? Well, we know that a percent is out of 100. So that's 67 times out of 100. And 50 times out of 100. So when it's asking which one is not likely, which one do you think it is? That is correct. It's the one that doesn't match up. So make sure you choose an answer. You're going to circle the answer that it is. It says which one is not likely. And our last question. A purple bag contains 8 red marbles, 3 blue marbles, and 4 green marbles. What is the probability that Amir draws a blue marble? Well, we need to know the part out of the whole. So how many total marbles do we have? 15 total. We have 15 total marbles. So what's the probability that he draws a blue? Well, how many blue ones are there? 3 out of 15. I know that can reduce because 3 goes into 15. So that's 1/5. What is 1/5 as a decimal? 0.2, which would be 20%. What is the probability that Layla draws a red marble, does not replace it, and then draws another red marble? This one is tricky. So we're going to draw a red marble. How many red ones are there? 8. And how many total? 15. So she draws 1 marble. Anytime you draw 2, you multiply. So if we have this bag of marbles and we pull one out of the bag, how many are left in the bag? 14. So the second one is only out of 14. Here's the other thing. It's saying that she pulls a red marble and she doesn't replace it. So there was 8 red marbles. Now how many red marbles are there? 7. When you multiply fractions, you multiply straight across. So straight across, we've got 8 times 7. 56, and then 15 times 14. All right, those are both even numbers, so I know they can reduce. You could do 56 divided by 2. $28, you could do 210 divided by 2. 105. I think that's as low as we can go. And then let's find out what that decimal is. I heard 53. Anybody else get something different? Yep, sometimes we make a mistake just typing it in. Common mistake. So 0.266. So I would say that that is not 27%. You're going to do the last two on your own, and any of the others that you didn't finish yet, we're going to grade this in like 10